Om Shri Sai Ram. Dear children, welcome you all to this class. Last class we have learnt about aromatic hydrocarbons and also we have learnt about structures like benzene, naphthalene, toluene structures and uses of hydrocarbons. Today's class we are going to learn about functional groups. First, what are functional groups we are going to discuss. In functional groups we are going to discuss about, we are going to discuss haloalkanes, alcohol and aldehydes. These three, haloalkanes, alcohols and aldehydes, will come under functional groups. Let us look at what are functional groups. Very basic and very important, children. Please concentrate. What are functional groups? Functional groups are specific group of atoms or bonds present in molecules that are responsible for the characteristic chemical properties of those molecules. Means they are specific group of atoms or bonds present in that molecules that are responsible for what? Characteristic chemical properties of that molecule. Means they are nothing but they are some specific group of atoms, or they are nothing but they are the bonds present in the molecules which are responsible for the characteristics of the chemical properties. Next, each class of functional group may be represented by the general formula. This is the general formula, that is Rx, where R is alkyl or aryl radical and X is the functional group. This is very important. The functional group general formula is Rx, where R is alkyl or aryl radical and X is the functional group. Let us look at haloalkanes. What are haloalkanes? Haloalkanes are group of chemical compounds derived from alkanes. CnH2n plus 2 alkane, single bond between the two carbon atoms, they contain single bond containing one or more halogen atoms. Halogen are in periodic table 17th group elements are called halogens, that is chlorine, bromine, fluorine, iodine. They are halogens. Means what are haloalkanes? Haloalkanes are a group of chemical compounds derived from alkanes but containing one or more halogen atom. Means they are containing one or more halogen atoms. Hydrogen atoms in alkanes are represented by halogen atom to form haloalkanes. Means here hydrogen atoms in alkanes, hydrogen atoms are replaced. In alkanes, any one of the hydrogen atoms are replaced by halogen atom to form haloalkane. This is very important point. This point is very important, children. Once again I am repeating, hydrogen atoms in alkanes are replaced by halogen atom to form haloalkanes. Next, halogens include fluorine, chlorine, bromine, iodine. That is the 17th group of elements. In a periodic table, if you open your periodic table, see 17th group, there you will find chlorine, bromine, fluorine, iodine, all these are halogens. Next, the general formula for haloalkanes is Rx. Very important. See here, Rx, where X is halogen, R is alkyl chain, X is halogen, R is alkyl chain. Let us look at the example for haloalkane. Let us know what is this is the structure of butane. Any one of the hydrogen atom is replaced by halogens, then it becomes haloalkanes. Similarly, see, when the hydrogen atom on first carbon atom, this hydrogen atom on first, this 1 2 3 4 1 2 3 4, when hydrogen atom on first carbon, means in first carbon hydrogen atom is replaced by chlorine atom, it forms 1-chlorobutane. See, if it is replaced by chlorine atom, it becomes 1-chlorobutane. If it is replaced by second carbon here, if it is replaced here, then it becomes 2-chlorobutane. This is the examples. If you know these examples, let us draw the structure for bromopentane. Very important. First, you write the structure of pentane. One, two, three, four, five. This is the structure of pentane. Now we have written pentane structure. Let us write bromopentane, means one of the hydrogen atoms. Here, see here. Here, in first carbon, hydrogen, one of the hydrogen atom is replaced by bromo, then it becomes bromopentane. This is the structure of bromopentane. See, this is 1-bromopentane. This is the structure of 1-bromopentane or bromopentane. One of the hydrogen atom is replaced by halogen. That halogen is bromo, that is bromine, Br. Then it becomes 1-bromopentane or bromopentane. Please note down this structure. Let us write fluorooctane. You know octane structure. Second is the fluorooctane. Fluorooctane. In first carbon atom, here one of the hydrogen atom is replaced by fluoro. Then it becomes fluorooctane. Please note down the structure. Very important, children. These structures are very important. This is example for fluoro octane. 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. In first carbon atom, one of the hydrogen atom is replaced by fluoro, that is fluorine, halogen. Then it becomes fluorooctane. This is nothing but 1-fluorooctane. This is the structure. Next, let us look at into alcohols. Have you understood what are haloalkanes and how to draw the structures? Let us look at into alcohols. This alcohols. What are alcohols? Hydrocarbons containing OH as functional group are called alcohols. Very important point here. Very important. Containing OH as functional group are called hydrocarbons containing what? OH as functional groups are called alcohols. They are represented by general formula ROH. The functional group in alcohol is OH. If you have to remember, this OH is the functional group for alcohols. Next, the name of alcohol is derived from the corresponding alkane by adding suffix -ol, means alcohol, butanol, pentanol, all alcohol, butanol, pentanol, means it's always what? The name of alcohol is derived from the corresponding alkane by adding suffix ol, that is all, alcohol. This is the suffix. Next, let us look at the example of alcohol. First, let us write the butane structure. This is the butane structure. And next, when the hydrogen atom on the first carbon atom is replaced by OH group, that is functional group, hydroxy group, it becomes 1-butanol. See here. Any one of, in first carbon, in first carbon, any one of the hydrogen, either maybe this, this, any one of the hydrogen atom is replaced by what? OH group. This OH group, hydroxyl group, it becomes 1-butanol. Butanol. This is the structure. Please note down. Let us draw the structures for propanol and heptanol. Let us draw the structures for first propanol. In first carbon atom, one of the hydrogen atom is replaced by hydroxy group. Then it becomes propanol. This is the propanol. This is also known as 1-propanol. Is the structure. Next, heptanol. In first carbon, one of the hydrogen atom is replaced by hydroxy group, OH group. Then it becomes heptanol. That is 1-heptanol or heptanol, OH group. This is the second structure. Please note down. Please note down these structures. Let us try one more structure. Write the structures for 3-heptanol. Write the structure for 3-heptanol. Yes. First you write this is 1, 2, 3. In third carbon, one of the hydrogen atom has to be replaced by OH group. Then it becomes 3-heptanol. Now we can write hydrogen atoms. This is the structure for 3-heptanol. Yes. This is about alcohols. Alcohols, you have to remember what is the general formula of alcohols? ROH. OH group, if in a compound, if it has OH group, then it is alcohol. What is the suffix? OL. Alcohol, butanol, heptanol, pentanol. That is, all is the suffix. Let us look at last functional group for today's class, that is aldehydes. What are aldehydes? Simple. Compounds containing, very important, this very important compound. Compounds containing what? CHO as functional group are called aldehydes. CHO as functional group are called aldehydes. The general formula for aldehydes is RCHO, and the functional group in an aldehydes is CHO. This is the representation of CHO. C double bond OH. This is the representation of functional, that is CHO, that is aldehyde. Next, the name of an aldehyde is derived from corresponding alkane by adding suffix -al. Al, that is heptanol. Pentanol, that is pentanol. Heptanol means you have to remember the suffix is -al. Al. Let us look at one of the example how to draw. Butane structure. This is the butane structure. Very important. When first carbon and its hydrogen atoms are replaced by CHO group, that is aldo group, aldo group, it forms one butanol. Means this entire carbon, first carbon and its hydrogen atoms, this entire carbon and hydrogens are replaced by what? CHO, this group. Then it becomes one butanol. Write down the structure of one butanol. Let us draw the structure for propanol, heptanol and pentanol. Very easy. You have to propanol. This is the structure for propanol. Please note down structure for propanol, heptanol, the first carbon and hydrogen atoms is replaced by aldo group, that is CHO group. Then it becomes heptanol. This is the structure for heptanol. Please draw the structure for pentanol. Let us try. Pentanol structure. This is the structure of pentanol. In aldehydes, you have to remember what is the general formula? RCHO. CHO is the functional group. Always suffix ends with al. CAL, all. Pentanol, heptanol, propanol means it ends with al. Let us summarize this. As today's class, we have learnt about what are functional groups. In functional groups, we have learned haloalkanes, alcohols and aldehydes. Let us summarize this. Class of organic compounds, that is haloalkanes. General formula Rx, where X is the halogen. Functional groups F, Cl, B, R, that is Br, I, fluoro, chloro, bromo, iodo. Next, IUPAC name of the butane derivatives, that is chlorobutane, that is IUPAC name. And the structure example, we have taken butane and we have replaced it on in carbon, first carbon of hydrogen atoms are replaced by chlorine atoms, then it becomes one chlorobutane. Similarly for alcohols, we have learnt about alcohols. General formula for alcohols are OH. Functional groups, that is OH, suffix ol, butanol, and formula, that is the structure example we have taken, that is one butanol. Next, aldehydes. What is the general formula? All CHO. Functional group C double bond OH. All butanol. Next, structures. Today's class, we have learnt about what are functional groups. Then in functional groups, we have learnt about haloalkanes, alcohols and aldehydes. For next class, we are going to continue with functional groups. And we are going to learn about ketones and carboxylic acid. For today's class assignments, let us look at into assignments. Draw the structure for the following compounds: bromopentane, hexanal, octanol, that is alcohol, it is aldehyde, it's a haloalkane, Next, identify the functional groups in the above compounds. You have to identify the functional groups. Next, define functional groups. For today's class, we are going to close this session. Please revise this session today only, and you have to read your textbooks. And if you have any doubts, we will clarify next class. For today, I will conclude. Thank you, children. Thank you for your cooperation. Sai Ram.